Hi, I am a Harmony student from the North Austin campus. If you'd like to see the connection between my PBL project and the Statue of Liberty, stay tuned. For those unaware of what a single replacement reaction is, a single replacement reaction, also known as displacement or a single displacement reaction, is a reaction in which one element trades places with another element in a compound. Take a look at this demonstration I've provided as an example. On the reactant side, we see magnesium, Mg, being synthesized with silver nitrate, AgNO3. After the synthesis is complete, notice how magnesium and silver have swapped places. The products of the chemical reaction are now silver and magnesium nitrate. Now my project involves performing single replacement reactions using aluminum and iron. Now that I know that you have a basic understanding of my experiment, let me explain to you what I did. Here's a picture as well as a list of my materials. In investigation 1, I asked the question, when aluminum is combined with solutions made up of copper chloride, copper sulfate, sodium chloride, or a combination of the three, will reactions occur? In my experiment, I diluted copper chloride with water and placed a crumbled piece of aluminum foil inside. After waiting 2 to 5 minutes, I observed the effects of the reaction. I repeated the following steps for the second time, this time using copper sulfate and water. I repeated the steps one last time, replacing the copper sulfate with sodium chloride. Next, I poured sodium chloride and water into the beaker containing copper sulfate and observed any changes that occurred. Lastly, I poured copper sulfate and water into the beaker with only copper chloride and observed any changes that occurred. In investigation 1, reactions occurred in every beaker except the beaker that contained only sodium chloride. Puzzled that my reaction didn't work, I did some research and learned that single replacement reactions only take place when a higher reactive metal replaces a lower reactive metal. When I placed the aluminum and the sodium chloride, a reaction didn't take place because sodium is more reactive than aluminum. When I combined copper sulfate with sodium chloride, that piece of aluminum now had a lower reactive metal to displace, copper, and that's why the reaction took place then. In investigation 2, I asked the question, what reaction will form from the combining of copper chloride and iron? In my second experiment, I combined copper chloride and water into a beaker and placed a strip of iron inside. In investigation 3, I asked the question, what reaction will form due to the combining of copper sulfate and iron? In my third experiment, I combined copper sulfate and water into a beaker and placed a strip of iron inside. Afterwards, I observed and recorded the reaction that occurred. Investigations 2 and 3 produced similar results to those of investigation 1. After placing the iron into the copper sulfate and copper chloride solutions, the piece of iron turned brown because the copper had displaced the iron. Single replacement reactions are everywhere. A well-known example of a single replacement reaction is the Statue of Liberty. The Statue of Liberty has copper on its outside and iron on the inside as support. As time passes, the copper begins to react with oxygen and turn green, which is known as verdigris. The iron on the inside of the statue begins to react with the verdigris. A single replacement reaction occurs in which the verdigris returns to its copper state, but the iron inner support oxidizes and rusts. In the 80s, the Statue of Liberty's entire inner support was replaced, partially because of this. For my ELA component, I wrote a narrative essay on my struggle to decide on what PBL project I wanted to do. If you'd like to see how I overcame my indecisiveness and finally settled on to a project, please check out the link to my website provided below.